Okay, this is the first page of section 4.6 in Math 31. And in this section, we're going to learn about what's called complex fractions. Now, a complex fraction is itself a fraction, but the parts of the fraction are also fractions. So you got it, for instance, here you got a fraction within a fraction. And that's what makes it a complex fraction. So there's simple fractions where the numerator and the denominator neither of them are fractions. And then you've got other ones where you got fractions inside the numerator, and you got other fractions possibly in the denominator, either both of them or maybe just the numerator, like that one where you got a fraction up there. Here you have one on the top, a fraction up top, and a fraction on bottom. So the numerator, the top part, is a fraction itself, and the bottom is also. And that's what makes these complex. Okay, so what we're going to learn here is two different ways of doing this. The first way involves division, and you interpret the fraction bar as a division bar. Then we're going to learn how to clear the subfractions. That'll be the second way to do it. So let's start with method 1. And in method 1, it's preferable not to use the diagonal slash style. It's preferable to write it vertically, so 3/5 straight up and down, 9/10 straight up and down. Now the middle bar there is a division bar. So this really is the problem 3/5 divided by 9/10. And earlier in the course we learned that you can always substitute multiplication for division of fractions, but you have to know that it's the second fraction that gets inverted. We call that the reciprocal. So I turn that 9/10 upside down. And once you've got it in multiplication format, then cross-canceling is on the table. You're allowed to cross-cancel. Here I divided the top and bottom by 5. And it's just straight across would be 6. That's the 3 times 2. And 1 times 9 is 9. And we're going to get, if you divide these both by 3, you're going to get 2/3 as your final answer. Now you may have noticed that I could have taken another shortcut. I could have divided that by 3 and this by 3. And then I'd have gotten that answer even faster, and I would have skipped this step right here. Okay. The second method is a way of clearing the fractions out of the numerator and the denominator, and we did something similar when we had equations. So what we've got here is a situation where you got to get rid of the subfractions, the ones on top and bottom, and you do that by multiplying by the least common denominator of those fractions. So let me illustrate here. This second problem here has a 4 as a denominator, a 3, and a 5. So if we can come up with a number that all three that are multiples of all three of those, we're going to be in business. So I usually start with the bigger one, the 5. 5, 10, 15, 20, and so forth. And if you keep going, the first number that all of them divide into is 60. So we're going to multiply the top by 60 and the bottom by 60. And that's called the least common denominator that we just found there. Now, when you multiply a whole number times a fraction, you're better off dividing the by 4 in this case. So divide first. 60 divided by 4 is 15, and 15 times 3 is 45. Okay, for the second part of this, you're going to go 60 over 3 would be 20. 60 divided by 3 is 20, times the 2 that's up top would be 40. So we're going to get a numerator of 85 on top there. This would be 120. And when you figure out the back half of this subtraction here, you go 60 divided by 5 is 12, and 12 times 4 is 48. So there you go. So we end up with 85 on top, and let me see, 72 on the bottom. And I don't believe there's any number that cancels out of those. 85 is 5 times 17, and neither of those numbers, 5 or 17, go into 72. Okay, so that does it for page 1 of the note set.